Okay, so this is to help on question, let's see, 15B and C. So on 15B, I believe the reaction is N2 plus 3H2 in equilibrium with 2NH3. I can write it in. All right, and it gives us a Kc. It says the Kc is 3.7 times 10 to the 8. All right, and we have to solve for Kp. So it's like, hey, if we go from having Kc, which is in concentration, to pressure, what's the pressure constant going to be? Okay, well, we know that Kp is equal to Kc times RT to the change in N, where our change in N always equals the final N final minus N initial. Well, our final number of moles over here is 2 from this 2 of gas. And our initial moles over here is 3 plus 1 is 4. So our finals minus initial is 2 minus 4. In other words, -2. So our delta N is equal to -2. All right, let's plug and chug. We have our Kc, which is 3.7 times 10 to the 8, times all in parentheses, our R, which is 0.08206 liters ATM over mole K, times our temperature, which was 298 K. My power is going out over here. All to the power of -2. Okay, so when you go through and you calculate this, make sure these are in parentheses and that you're putting it to the power of -2 before you multiply it by that. And when I do that, I get an answer of 618,737. And I just moved the decimal place 1, 2, 3, 4, 5 times. In other words, 6.2 times 10 to the 5 would be my answer for 15B. So I hope this helps. Mistakes that I made when I was doing this is just not thinking through the right R, or maybe not putting in parentheses, etc. All right, and let's move on to 15C, which is a similar problem. Here we have N2 plus O2 in equilibrium with 2NO. And our Kc here is 4.10 times 10 to the -31, something with 3 sig figs. And oh, we should go back to this. This has 2 sig figs because that had 2 sig figs. This would have had 4, that has 3, etc. So we ended up with something with 2, 4, 3, 2 is the smallest, so that had 2. In case that comes up. Okay, and then we have this one where we're gonna say same thing. Our problem is Kc times the RT to the delta N is going to be equal to our Kp. The beautiful thing here is our delta N, this has 2 moles of gas on this side, and this has 1 plus 1, which is 2. So our delta N, our final minus initial of N's, is equal to 2 minus 2, in other words, 0. Cool? So when we do this, our Kp is going to equal to our Kc times RT to the 0 power. And remember, anything to 0 power is just 1. In other words, our Kp equals our Kc. And because our Kc is 4.10 times 10 to the -31, that will also be our Kp. So cool, I hope that helped, and that would be your answer for Kp as well. Bye. Sorry for all the noise.